Now, so you just look at the question, find the Norton's equivalent circuit. Okay, so some circuit is given. So you got to find the Norton's equivalent circuit. Norton's equivalent circuit is current source in parallel with the resistance. So this is the Norton's equivalent circuit. Okay, this is IN, this is RN. So this is the terminal A, this is the terminal A, and this is the terminal B. So this is terminal A and this is terminal B. So you have to find out the Norton's equivalent circuit. This is the Norton's equivalent circuit. You have to find that. So you have to find out what is Norton's current and what is the Norton's resistance. Okay, we are going to find that. Then we will draw the connection between A and B. We have got the resistor, 40 ohm resistor is there between A and B. So this is our RL. This is our RL. Okay, so we got to find out IN, RN, then you have to find out current flowing through RL. So they using the formula, you have to find out the current flowing through RL. Okay. Now first step is step one. Step one is, please be fast students. Step one is calculation of IN. So IN is otherwise called the short circuit current. Short circuit current. Okay. So for the short circuit current, wherever you have, this is my RL. Okay, this is my RL. So the RL has to be replaced and we have to make it short circuit. You have to make it short circuit. Please draw this diagram, students. Quickly you draw. So this is the short circuit current, ISC. Otherwise, this is equal to Norton's current. Have you noted the circuit, students?
Yes, sir.
Okay. Now, how to find out current flowing through the central short circuit branch? Which method I can use? Which method I can use to find out current flowing through the central branch, short circuit branch? Even answer is wrong, no problem. You say which method could be useful, because I got two voltage available, two loops are available. So which is
Sir,
easiest?
mesh analysis.
Mesh analysis. Very good. So I can go for the mesh analysis. So this is I1 and this is I2. Okay. So what is the current flowing through the middle branch? Short circuit current is going to be what in terms of I1 and I2? Tell me.
I1 minus I2, sir.
I1 minus I2. So Norton current is I1 minus I2. So you have to find out I1 and I2. So mesh method, using mesh method. Okay. So who will give the values for the mesh method? Can I have some volunteer? Can I have some volunteer? Saivi, can you tell me the values of the mesh method? Elements, entries? Saivi. Resistance available in the first mesh. How many resistors are there?
Sir, 1.
1. Or tell me the sum of that.
Sir, 10.
10. Okay. Then second mesh?
20.
20. Okay. Common between first and second?
0, 0.
0, 0. This is I1. This is I2. Tell me the voltage then.
Sir, 10.
10.
And minus 20.
Minus 20. Okay. Now it will get me the value of I1 and I2.
I1 is 1.
I1 is
1, sir.
1 amps. I2 is
Minus 1.
minus 1. Okay. Now short circuit current and the Norton current is equal to I1 minus I2. I1 minus I2. So I1 minus I2 is I1 minus minus 1. It is going to be how much current? 2 amps. So this is the Norton current. Is that clear, students? Is that clear? Shall we move on?
Yes.
Yes or no?
Yes, sir.
Okay, what is the second step? Step 2. What is the second step?
So calculation of Rn.
Calculation of RTH.
Rn, sir.
Aryan, very good, very good. Rishika. Rishika is very clear. We should not do RTH. It is Rn. So it is the calculation is equal to RTH, but we should not write RTH. It is Rn. Okay, what is the procedure to be followed for Rn or RTH? We have to make the sources. We have to remove the sources. So we have got voltage source. We have to make the voltage source to short circuit. And here also another voltage source, we have to make it short circuit. There is no current source available, so open circuit is not required. So you got to find out the resistance between the terminal A and B. So this resistance you got to find out, RTH, Rn, we have to find out. Okay. Now if I ask you series or parallel, can I have some response? It is series or parallel? Between the resistance between A and B, the 10 ohms and 20 ohm are connected in series or parallel?
Parallel, sir.
Parallel.
Parallel. Okay. Rishika says it is parallel, and there would be some other. Can I have some other answer? I'm not saying that whether it is parallel or series. Rishika says it is parallel. Okay, others?
Parallel, sir. Parallel.
Parallel. Okay. Now I'll make this diagram very simple. What I'm going to do is I'm taking this 10 ohm this side, this 20 ohm this side. So I can take it, right? So this 10 ohms here, 20 ohm here. This line I'm joining together. This line I'm joining together. This line I'm joining together. This A I'm taking it out. This A I'm taking it out. A and A. Okay. If you are very clear with the parallel, you are 100% understood about the series parallel combination. So right, I am happy about it. This is 10 ohm. This is 20 ohm. Okay. So RAB, RN is 10 and 20 are in parallel. 10 and 20 are in parallel. So 10 into 20 divided by 10 plus 20. So can I have the value of the Rn? Please, quick, students. Please try to use the calculator with you. Keep the calculator
Sir,
with you.
6.67.
6.67 ohm. Please keep the calculator with you. Okay, have the calculator with you nearby. Then and then you have to use the calculator immediately. If you don't have the calculator, if you have kept the calculator in the college, please try to get some calculator from your neighbor or somebody who knows who is using the calculator. Okay, your mobile phone may not help you in all ways, right? Mobile phone calculator is different from the normal calculator. Don't just rely on the mobile phone. Have a calculator. If you have kept your calculator in the college, right, try to get a calculator from somebody who is nearby. So nowadays the calculators, everyone is having the calculator, scientific calculator, right? Now what is the third step, students? Now step 3. Step 3 is what?
Norton's equivalent circuit, sir.
Norton's equivalent circuit. Norton's equivalent circuit. Okay. Now the diagram is drawn with the 2 circles. Okay, I'll draw with single circle. No problem. Don't worry. Okay. So don't just copy this diagram. I'll draw another diagram for your understanding, which we are following. Okay. This I have taken from somewhere. So this is Norton's current. This is the Norton's resistance, and this is resistance A, and this is resistance B. Sorry, terminal A and terminal B. Between the terminal A and B, what is the value of RL? Can I have the value of RL? Can I have the value of RL? Don't take this diagram.
40, sir.
40 ohm. Okay. What is the value of Rn? Rn is 6.67 ohm. What is the value of In? In is 2 amps. Okay. 2 amps. Is that okay, students? Is that okay?
Yes, sir.
Yes. Now, so we are going to the step 4. Last step. Okay. Step 4. Step 4. Calculation of load current. Calculation of current through 40 ohm. 40 ohm. That is IL. That is IL. So you know the formula. Please refer your notes, students. IL is equal to. Can somebody say the equation for IL? Somebody can give the equation for IL, which I have given earlier. In
So IN
expressions
into
again.
RN.
by
IN into
RN.
RN. Very good. Divided by
Rn plus
RN plus RN.
RN plus R. So IN is known to you. IN is 2. RN is 6.67. Okay. Divided by RN is 6.67 plus 40. You will get the current, final current. So this is how we have to solve this problem. Is it easy now?
Yes, sir.
Okay.